everyone, welcome to the Lee County Library Science Club. Now, since we're all stuck at home for a little while and we can't come hang out in person and try stuff, we decided that we would demonstrate some experiments for you so that you can try them at home. Now, all of the experiments that we're going to do over the next few weeks do have a little bit of risk to them. Alright? So make sure that you're doing them with your parents' permission and with some supervision. Now, with that said, what we're going to be doing today is we're going to use chemistry to magically put out a fire. Okay, maybe not exactly, but what we are going to do is put out this candle without touching it or blowing on it or anything like that. Yeah, it's still pretty cool, right? What we're going to need for our experiment today, we need a small glass, a large drinking glass, a little tea light candle, some baking soda, and some white vinegar. Right. First things first. What we have on the candle is fire. But what is fire really? So fire is what's known as a combustion reaction. And a combustion reaction needs three parts to it. It needs oxygen, like the air we breathe. That's oxygen, right? Alright, so it needs oxygen, then it needs fuel. And fuel could be a lot of different things. It could be wood, paper, oil, but for us today, the fuel is candle wax. The last thing it needs is heat. Now what I'm going to be using is just this little regular old lighter. Alright, and that creates the initial heat. But the cool thing about fire is that once it gets going, its own heat is what keeps it going. So, just to cover it again, fire needs three things: oxygen, fuel, and heat. Now, if you want to learn a little bit more about fire, feel free to go online, again with your parents' permission. Alright, go online and search for something like chemical combustion or burning reactions, something like that, okay? And you can learn a little bit more about what fire actually is. The second concept that we're going to be using today is the reaction between acids and bases. So acids and bases are types of substances that will react with water. And that seems a little odd, right? Because we drink water all the time, it's kind of everywhere. We wouldn't think that it's all that reactive or harmful or anything like that. And really it's not. But what water is made of is 2 hydrogen atoms and 1 oxygen atom. And the interesting thing about that is that hydrogen is one of the most reactive elements in the world. What's happening with acids and bases, an acid, like this vinegar that we're using today, an acid is a molecule that is able to give away a hydrogen atom. Okay? And on the other hand, a base, like our baking soda, is a molecule that is able to receive a hydrogen atom. So it would make sense that if water is using a lot of hydrogen atoms, it would interact in interesting ways with both acids and bases. But what we're actually doing today is using our acid and base together to create something else. A lot of you have probably seen or know of the fact that vinegar and baking soda, when you put them together, they kind of blow up, right? Alright, but what's actually happening there is they are mixing together, they're mixing all up, and they're creating water, carbon dioxide, and acetate. What we are focusing on today is not really the water or the acetate, but actually the carbon dioxide that's created from this acid-base reaction. Now, if you want to learn more about acids and bases, I would suggest looking up things like the pH scale or hydrogen reactivity, or even just acids and bases when you go search for it. Now again, I said we were focused on the carbon dioxide that comes out of this. And why is that? Well, carbon dioxide is denser than oxygen. And what is density? Well, density is kind of how closely packed together the molecules of a certain substance are. Now, it's easy to see when we look at the types of matter, okay? We have solids, we have liquids, and we have air that just kind of floats around. Now, a solid, those molecules and particles, they're pretty tightly packed together, they can't really move very much, and they're just kind of stuck. In a liquid, the particles are still kind of connected to each other, but they can wiggle around and move, and it kind of sloshes around. Now in air, the molecules, those particles, are spread out a lot more, so they can just kind of fly around all over the place, right? But what's cool is that you can have different densities between stuff of the same type of matter. So in this case, we're talking about oxygen and carbon dioxide, which are both gases. But oxygen is less dense than carbon dioxide. Now, why does that matter? Well, density also impacts how much of an effect gravity has on a substance. That is why I can stand here and not float away into the air, okay? Because me, which is a lot of solid and a lot of liquid inside me, I am more dense than the air around me. So I stay down here on the ground. So what that means is, when we have oxygen and carbon dioxide, if they're kind of floating around, but they come close to each other, the carbon dioxide is going to come down below and push the oxygen up, because the carbon dioxide is being pulled more by Earth's gravity. So, if you want to learn more about density, you can go online, again with your parents' permission, and search for things like density, air pressure, or even just ask them, hey, why do I float? Alright? Now, let's get to our experiment. What we're going to do, we're going to pour half a cup of vinegar into our big cup, and we're going to mix half a teaspoon of baking soda into it. Now, like I said, when this happens, can create a pretty big reaction. It kind of blows up all over the place. But today, that's actually not really what we're going for. So when I add my baking soda, it's going to be nice and slow. But like I said before, the reaction between these two that's going to happen, you'll see the bubbles and it'll fizz, and what's happening while it's bubbling up like that is it's releasing the carbon dioxide. Now, because most of the air around here has a lot of oxygen in it, the air here is less dense, so the carbon dioxide is just going to kind of stay in this glass. So what that means is we can take the carbon dioxide from here and pour it out, and, well, you'll see what happens. Now, so I'm going to start with my vinegar. Next, I'm going to add my baking soda, about a half a teaspoon. Like I said, we want to do this kind of slowly so that it doesn't just blow up all over our table. Alright, you see it foaming up there? All those bubbles are the reaction happening, and as they pop, they're releasing the carbon dioxide. And that carbon dioxide, as the bubbles go down, carbon dioxide is filling the glass up. Alright, so now that it's starting to die down, that means we've got a glass full of carbon dioxide. We're going to take it, pour it over our candle, and poof! It's gone. Just like that. Now why did that happen? How did that happen? Well, remember what I said back at the beginning. Fire needs three things: fuel, heat, and oxygen. But, as we just talked about, carbon dioxide will move oxygen out of the way when they're in an enclosed space. So what we had that fire going, and we had all the oxygen in here fueling the fire, keeping it going. But when we poured our carbon dioxide in, all the oxygen that was in there, the carbon dioxide pushed it right out. Now a fire can't burn on carbon dioxide, it needs oxygen. And so, as soon as that oxygen was taken away, poof, the fire is gone. Now that is some cool stuff, isn't it? Feel free, like I said, with your parents' permission and supervision, get some baking soda and some vinegar and see if you can put out a candle without touching it. Alright? Thanks so much for joining us, and hopefully we'll see you next week. Bye!